Welcome to another Titus Timeout podcast. I'm Phil Baxter. I'm the Terminal Unit and Underfloor Applications Engineer here at Titus. Today I'd like to talk to you about parallel fan box fundamentals, how a parallel fan box works, and lastly the pros and cons of operating a parallel fan box in an office environment. The Titus Terminal Unit Application team answers many calls on how exactly a parallel fan box operates. During today's podcast, my hope is to answer many of the common questions that have been asked about the operation of parallel fan boxes. First, let's discuss how a parallel fan box operates during a cooling call. During a cooling call, the electric motor in a parallel fan box is de-energized. While in this state, gravity takes over and keeps the internal backdraft damper in the closed position. While the backdraft damper is in the closed position, only 100% primary air is introduced into the occupied zone. In my example, the primary CFM is set to 1000 CFM. This primary air is generally a mixture of recirculated building air and a percentage of fresh outside air which is passed through the box using pressure generated from the building air handler's fan. In most cases, this primary air is at or near 55 degrees Fahrenheit. While in the cooling mode, generally zero plenum air is mixed with the primary air. Now let's look at how a parallel fan box operates during a heating call. During a heating call, the fan box electric motor energizes, which opens the internal gravity damper. At or about the same time, the primary damper modulates to a programmed minimum CFM during the heating position. Let's look at an example where the electric fan motor is providing 600 CFM of plenum air. Plenum air is generally warmer than primary air. The primary air is in turn providing 150 CFM. Both the primary and plenum air are mixed together with a total CFM of 750 introduced in the occupied zone. Remember, with parallel fan boxes, the rule is primary CFM plus fan-generated CFM equals the total heating CFM delivered to the occupied space. Not understanding this basic principle is by far the biggest misunderstanding we see in parallel fan box selections. Now that we've gone over how the parallel fan box operates, let's discuss some talking points on parallel fan boxes. First, remember the electric fan in a parallel fan box is designed only to energize during a heating call. When selecting parallel fan boxes, the building engineer has the ability to select a smaller fan motor because the fan only has to generate the CFM needed during the heating mode. Parallel fan boxes use a greater percentage of warm plenum air to heat the occupied space, which is at a significantly higher temperature than supply air. This equals energy savings. Total primary CFM introduced during heating mode is usually dependent on the needed outdoor fresh air ventilation requirement for the area being serviced. Now let's discuss the typical fan box applications. Parallel fan boxes are used in areas where there's a requirement for a minimum high turn down on primary air. The parallel fan box are utilized as perimeter boxes in traditional VAV systems where the fan box can use free plenum heat to offset the building skin loss. Parallel fan boxes also are best used in schools, office buildings, perimeter zones, and buildings with varying heat loads. Now let's go over some pros with parallel fan boxes. With parallel fan boxes, only the required amount of primary air is used, conserving primary fan power energy. Parallel fan box electric fans only operate during heating mode, which conserves energy. The fixed supply air temperature maintains humidity control in the space. They can also be set up to provide a fixed amount of outside ventilation air per building space. Also, let's see some cons for the parallel fan box. The fan box fans cycling on and off can be distracting to building occupants. they provide each zone with the correct amount of air is more difficult. Possible backdraft damper leakage at elevated downstream pressures can occur. I hope you enjoyed today's Timeout podcast, and don't forget to subscribe to our YouTube channel to hear future exciting Timeout Titus podcasts.